See, first now we need to check for the all length palindromes. In the scenario, when we are going to solve the question, first consider an example. See, just take a tape in which we have first blanks and we have our string. Example, consider a palindrome. What is meant by palindrome? A given string is said to be a palindrome if the reverse of the string is also the same string. Example, if the input is A, B, B, A, if you reverse the string, we will get again A, B, B, A. Then it is known as palindrome. Now, we need to solve it using Turing machine. My idea is, first, in Turing machine there will be blanks. Wait, I will write the same string, somewhat big string. A, B, A, B, A, B, B. Something, the blanks are present, and before the same blanks are present. Now we need to tell this is a palindrome or not using a Turing machine, which halts if the string is valid. It will not halt if the string is not valid. My idea is, first input tape is present here, the input header. Now I will check with this thing with last thing. If both are same, then I will replace it with blank. Then I will bring the header again back. I will check for these two. If these two are same, I will replace it with blank. And I will check for these two. If both are same, I will replace it with blank. But when we consider the Turing machine, at a time we can only remember one word, means A or B. If I am going to from here to here, I can remember only one thing. I had read A. But so that I made two divisions. One thing is starting with A, starting with B. If starting with A, I will go with this way. If starting with B, I will go with this way. In my Turing machine, according to my conditions, I am showing how to design a Turing machine. First, I will tell the way. If I am starting with A, divide. I will go with this way. If I am starting with B, I will go with this way. Now first I will start, and if A, if anything, I will go on. If blank is occurred, I will move left. If remembered thing is A, because for A I went this side. If the same thing is A, then I will mark it with blank and I will traverse again back. Again, if I occurred black, I will move right. Now I got B. If B, then I will go this way. Again, simply same procedure, I will move on. If I got blank, again move left. Here also B, blank. Again move, traverse left. Again I will come to here, A, remember A, go with this way. And come again here, blank on blank, move left. This is A. Now I will show you with another example in a clear way, I think, in a clear way. A, B, A, blank, right? First, I will start from here. This thing is A. I remembered A and I replaced it with blank. I will go on. When blank is occurred, I will move left. Left thing is A. I remembered A and this is A. So I replace again it with blank. Means up to now it is palindrome. I need to check for the inner thing. Now I will come back. If blank is occurred, move right. Now I will check this. It is B. I will replace it with blank. I will move right. Here blank. So again I will move back. Here it is also B. It is blank. Now I will move back. There are no A and B's, only blanks. Then it is final and we need to accept the string. Now how to consider, how to design the Turing machine. Whatever I told, just simply express in the form of commands in Turing machine. See, first I will start with S1, initial state. See, initial state, as I told, for A 1 branch, for B 1 branch. I am considering 2 branches, S2, S3. If first what I did for A, move right, replace with blank. For A, replace it with blank, move right. For B, same thing. We need to replace for B, replace with blank, move right. Now see, first I replaced it with blank, then I need to leave all the things. I need to go for last blank. Means I am writing the condition. that on A, replace it with A. Just simply move right side, right side, right side. If B, we need to replace it with B and move right. Same thing for B's also. For A, move right. For B, replace it with B, move right. Now, I replace it with A. If I am going this way, I remembered A. If I am going this way, I remembered B. I am going till here. I got a blank. Then what I should do? I need to come before. So, I am going to new state. On blank, blank, move left. Here also, blank, blank, move left. Write some state names. S4, S5. Now, if for the branch A, the preceding one must be A. Consider one another state S6. If I got A, because if I keep a loop, for A it will skip, for remaining A's I need to leave now. So I am entering into a new state. If you can minimize the Turing machine, you can minimize. It's our own Turing machine. We can write how many states we want. For A, I am moving with replacing it with blank and moving left. Here in case of B branch, I mean in case of B, I will move left by replacing blank. Now for A, going in front, I replace it with blank. We need to come back now. For coming back, I am writing one loop like B on B, move left. A on A, move left. Means I am not changing anything in the internal string. Last two are same. Means up to here, no problem of palindrome. We need to check for the initial string. Means initial string means we need to send for initial now. We have solved the string. Again, we need to start the same procedure for internal string. See, S6 means this thing completed. We need to go here and we need to start it as, we need to consider it as another string. We need to start again Turing machine. So see, S6 means we have replaced A. S6 on B comma B, move left. A comma A, move left. A comma A, B comma B, move left. A comma A, move left. A comma A, move left. B comma B, move left. A comma, here blank. Blank on blank means we need to move right. We need to check for this now. So blank on blank, move right. See, first for A, B, B, A, blank, A, B, B, A, blank. First it will verify S1 to A on blank, move right. A on blank, move right. A on A, move right. B on B, move right. B on B, move right. A on A, move right. Again, blank on blank, move left. A on B, move left. Sorry, A on blank. On A, we need to replace with blank. We need to move left. B on B, move left. A on A, move left. B on B, move left. B on B, move left. Blank on blank, we need to move right. Because up to here completed, we need to check for internal string. Again, we came to initial state. See, on B, we are coming with another branch. B replaced with blank, move right. B replaced with blank, move right. And we need to skip all the B's and A's. I have skipped, I had came here, blank on blank, move left. For this B, we need to replace with blank. B replace with blank, move left. Now the string is completed. Means the string is palindrome. If all the presence of blanks, it represents that the string is right. Now we will come to here now, blank on blank, blank on blank, move right. Again we got the blank. Means the string is completed. Now we need to keep a final state. Blank, blank on blank, move right. S7, S1 2 3 4 5 6 7, accept the string. Now how to write the table? See, this thing is simpler because writing the logic into the Turing machine is difficult. Meanwhile, writing the table is very easy because S1 on A, go to S2, blank right, same thing, just copy. See, S1 on A, move, because I have changed the Turing machine. See, I have changed the name of the states. Okay, it's fine. You see for these two, S1 on A, move to S2, replace with blank comma right. S1 on A, move to S2, replace with blank comma right. Right, similarly remaining all the table. Right, just see the strings. S1, sorry, S2 on A, move right. S1 on 2, S1 on A going to S2, replace with A, move right. S2 on A, going to S2, replace with A, move right. This is the thing. This is all even length palindromes. If you observe, if you solve even length palindromes, it is fine. But even length palindromes are subpart of odd length palindromes. If we solve the odd length palindromes, automatically even length will be solved. Now consider an odd length palindrome. A, B, A, B, A. We will replace it with blank. We will move right. We will replace it with blank. See, again coming back, we will replace it with blank. We will replace it with blank. For A, you will first replace it with blank. You will move right. You will not find A. Then according to this, you will tell that it is not a palindrome. But for odd length, it is. We are given a question that all length palindromes means odd length palindrome also we should accept. For that, there is one condition that here we need to change that blank on blank, move left. Blank on blank, move left. Why? I will say for A we have move right. We replace it with blank. I am going right until the occurrence of blank. Here it will be blank. Here it will be blank. For A I replace it here with blank, blank, completed. I will come back. For B also same, I will do blank, blank. After the completion of input, for the substring we will go for initial state. Now from initial state, A comma blank, move right. A comma blank, move right. See, if the string is only A, what we should do? It is an odd length palindrome. For A, replace it with blank, move right. Here there are no A's, there are no B's. For blank on blank, move left. If it is also blank, then the length of the string is odd. If it is also blank, then we need to accept blindly because it is an odd length palindrome. That's it. You fill the table in just simply way, just S2 on B, go to S2, blank, move right. This is the logic behind all length palindromes, how to solve this palindrome.